Every time you turn on the tap, water shows up like magic. Cold, clear, instant, no waiting, no second thought. Most people use it, spill it, waste it, and move on with their day, but almost nobody stops to ask one simple question. How do millions of gallons of dirty river water become clean drinking water every single day? And here's where it gets interesting. Because behind that simple kitchen faucet is a machine so massive, so expensive, and so complex, it feels more like a hidden factory than a public service. Today, we're going inside one of America's biggest water treatment plants. The kind of place built to supply entire cities, power neighborhoods, protect public health, and quietly keep modern life running. And once you see what it really takes, you may never waste water again. Most people imagine water treatment as a few filters, some pipes, maybe a giant tank. That image couldn't be further from reality. These facilities often cover hundreds of acres. Some process hundreds of millions of gallons per day. That's enough water to fill stadiums, feed hospitals, wash streets, cool buildings, and keep millions of people alive. And the craziest part? Most of it happens in silence. No spotlight, no headlines, no applause, just engineers, operators, pumps, sensors, chemicals, electricity, and non-stop pressure to make sure nothing fails. Because if this system stops, a city feels it fast. No showers, no restaurants, no hospitals functioning normally, no fire protection, no business as usual. Water is one of the few systems society notices only when it's gone. So where does it begin? Usually far from the city. The raw water may come from rivers, lakes, reservoirs, or underground sources, but don't let the peaceful view fool you. That water can carry mud, algae, bacteria, pesticides, runoff, industrial residue, and microscopic contaminants you'd never see with your eyes. What looks calm on the surface can be chemically chaotic underneath. That's why the first stage is intake. Massive tunnels or pipelines pull water into the plant, using pumps powerful enough to move unbelievable volumes every hour. Then the screening begins. Large metal grates catch branches, trash, leaves, plastic, and debris. Think of it as the first line of defense. And yes, sometimes workers find things far stranger than branches. Tires, furniture, animal remains, random junk people dumped upstream years ago. This is the part nobody shows in polished commercials. Because fresh, clean water sounds better than we removed a lawn chair from your future shower. After screening, the water moves into one of the most important stages, coagulation and flocculation. Sounds technical, but the idea is simple. Tiny dirt particles floating in water are too small to settle naturally. They just drift around. So operators add treatment chemicals that make those particles clump together into larger, heavier masses called floc. Imagine dust in the air suddenly sticking together into snowballs. Now it can be removed. Huge, slow-moving paddles turn the water gently, helping those particles collide and grow. This part requires precision. Too little chemical and the particles stay suspended. Too much and you create new problems. So trained staff constantly test pH levels, turbidity, flow rates, and water quality in real time. This isn't guesswork, it's chemistry under pressure. Then comes sedimentation. Massive basins allow gravity to do the work as the heavy floc sinks to the bottom, forming sludge while cleaner water rises to the top. It looks calm and slow, but underneath, giant scraper systems continuously collect the settled waste. And that sludge, it doesn't just disappear. It has to be processed, dewatered, transported, and handled under strict environmental rules. Even the waste from clean water costs money, which is one reason your monthly bill is higher than people expect. You're not paying for water. You're paying for an invisible industrial operation running 24 hours a day. Next comes filtration. This is where water passes through layers of sand, gravel, anthracite coal, or advanced membrane systems depending on the plant. Think of millions of microscopic traps catching what previous stages missed. Tiny particles, parasites, remaining sediment, and organic matter. Some modern plants use membranes with pores so small they block contaminants at near microscopic levels. But cleaner water comes with a price. These filters must be cleaned constantly using backwash systems that reverse flow and blast trapped material out, which takes more pumps, more energy, more maintenance, and more labor. Clean water isn't cheap because dirt is stubborn. And then comes the stage most people know about: Disinfection, where dangerous microorganisms are neutralized using chlorine, ozone, ultraviolet light, or a combination of methods, because even crystal clear water can still carry invisible threats. History proved that long ago, as before treatment systems, diseases spread through water supplies and wiped out communities. But modern water treatment didn't just improve convenience, it changed human life expectancy, which is why these plants are some of the most valuable infrastructure ever built. Not glamorous, not flashy, but life-changing. Yet getting water clean is only half the battle. Getting it to millions of people, every hour of every day, is where the real challenge begins. Because once treated water leaves the plant, it enters a hidden maze most people never think about: underground pipes, pressure zones, storage tanks, pumping stations, valves, backup systems, and emergency controls spread across entire cities. Some of these pipe networks are older than the people using them. In parts of America, water mains were installed generations ago. Cast iron, steel, concrete. Infrastructure built when the population was smaller, demand was lower, and modern contamination risks barely existed. Now those same systems are expected to serve growing cities, apartment towers, hospitals, schools, factories, and data centers around the clock. That's a heavy burden for pipes buried decades underground. And when one fails, it fails publicly. Roads flood. Traffic stops. Businesses close. Boil water notices go out. Repair crews rush in while everyone asks the same question. How did this happen? The honest answer: because maintenance is expensive, invisible, and easy to delay. Replacing 1 mile of water main can cost millions. And unlike a new stadium or flashy downtown project, nobody takes selfies with upgraded underground pipes. So many cities postpone repairs until something breaks. That's the hidden economics of infrastructure. You only notice what politicians cut ribbons on. You rarely notice what quietly prevents disaster. Inside the plant, operators know this reality better than anyone. Their job doesn't end after treatment. They monitor pressure swings, chemical residuals, storage levels, pump performance, weather changes, demand spikes, and emergency alerts. Hot summer day, demand surges. Major fire in one district, pressure priorities change. Power outage, backup generators must activate immediately. Heavy rain upstream, source water quality may suddenly shift. Every hour creates new variables, which means many plants operate more like mission control than a utility building, with walls of screens. It's complacency. When systems work for years, people assume they'll work forever. Budgets get trimmed, repairs get delayed, staffing gets reduced, training gets skipped. Then one storm, one broken pump, one contamination event, or one aging main rupture exposes years of neglect in a single day. That's why some of the smartest money a city can spend is on things residents barely see: backup pumps, leak detection systems, pipe replacement schedules, cybersecurity for plant controls, emergency reservoirs, skilled operators. None of it feels exciting, all of it matters. And yes, water has become a money issue too, because across many places utilities are trapped in a brutal math problem. Aging infrastructure, rising labor costs, stricter regulations, climate pressure, and growing demand. Someone pays for that, usually through rates, taxes, or debt, which is why your water bill may rise even when usage stays the same. You're not just paying for water flowing today. You're paying for repairs from yesterday and reliability for tomorrow. And compared with bottled water, restaurant drinks, streaming subscriptions, or daily coffee runs, municipal tap water is often still one of the cheapest essentials people buy. Gallons for pennies, delivered to your house, tested, treated, available in seconds. Value that's easy to miss because it feels so normal. Then there's the future, as America's biggest treatment plants are changing fast. Some now use AI-assisted monitoring to predict failures before they happen. Some recycle wastewater into potable supplies, and some capture methane from sludge to create energy. Some use smart meters to detect leaks in homes before owners even know there's a problem. Others are redesigning around drought, floods, and population shifts, because the next 30 years won't look like the last 30. Climate volatility, migration, and aging infrastructure are rewriting the rules. The cities that invest early may thrive, while the ones that delay may pay far more later. And that's another lesson hidden inside water treatment. Preventive spending usually feels expensive, until compared with emergency spending. So what don't they show you about America's biggest water treatment plants? They don't show the midnight crews responding to alarms, the chemists testing samples hour after hour, the rusted pipes being replaced under traffic at 2 a.m., the sludge hauling, the power bills, the maintenance schedules, the risk planning, the backup generators waiting for storms. They don't show how many people work quietly so millions can live comfortably, and they definitely don't show how fragile modern convenience really is. Because the moment water stops, everyone suddenly understands its value. Until then, it's just a faucet. So next time you fill a glass, wash dishes, take a shower, or hear water running down the drain, remember, you're touching one of the most complex public systems ever built, a system of engineering, chemistry, labor, logistics, and constant vigilance. All to make something difficult feel effortless, and maybe that's the greatest sign of world-class infrastructure. When it works so well, nobody notices it at all. If you enjoyed this deep dive into the hidden systems that keep society running, subscribe for more stories where money, engineering, and everyday life collide.